Hey everyone, in this tutorial we are going to build a Freshdesk app that is going to integrate with GitHub. As you might already know, GitHub is a code hosting platform that contains lots of code repositories and has features for collaboration and version control. Our app will be making use of the platform features to create issues in GitHub from Freshdesk tickets. We'll also cover some of the important features which are the building blocks for Freshworks app development. You would have already been introduced to a few platform features like data storage, request methods, installation parameters, and so on. In case if you have missed these sessions, don't worry. You can always find the relevant information in code labs, or developer docs, or in the session links that are shared in the chat. In today's session, we will specifically cover how to access GitHub-based APIs that are secured with OAuth 2.0. Along the way, we'll make use of the instant methods to create modals and display the issue details right inside Freshdesk. But before we dive in, there are a few prerequisites. So you need to have the boilerplate for the code that we are going to use today. So you can clone it from the sample apps repository based on the snippet that's here. And once you're done, also make sure you have a trial Freshdesk account. You can easily sign up using this link that is present in the code lab. And you also need a GitHub account. I guess most of you might already have it, but in case if you don't have it, please create one. And all right, so now that we have all the prerequisites, we can get started. All right, I'm going to clone the marketplace sample apps, which contains a boilerplate for my application. And once it is done, I will switch to the directory under which the sample app is present. Alright, I am in the sample app directory. As you can see here, you can notice two different directories, completed and start. So you can cd into the start directory if you want to start fresh, and you can copy a few snippets from the code labs and then eventually build your complete app. So I'm going to do that, and I have cd'd into the start directory. But if you directly want to know how the app works, you can also very well jump into the completed directory and then do an fdk run and then see the output. So since I'm going to start from the boilerplate or the starter, I am cding into the start directory. So as you can see here, the start directory contains the actual app. Of course, it's not a complete app. It has few things that needs to be done in order for us to have a working application. All right, now let's open the directory in a code editor. I am using Visual Studio Code, but you can use whichever you prefer. Let me increase the zoom. I hope it's visible. Okay, a quick overview of the app structure before we start coding or before we start diving into the code labs. The manifest.json right here. Let me zoom it a bit. Yeah, this one. So the manifest.json right here describes the product for which we are building the app, as you can see here, and also other details like app location, dependencies, and so on. The config directory, which is right above the manifest.json, it contains app-specific configurations. For example, you can see the config file which is associated with installation parameters and OAuth already here. We'll cover them in detail gradually, but for now, think of them as simple abstractions that the platform offers, which otherwise has to be coded manually. The app directory, which is right above the config directory, it contains all resources specific to the front end of the application. These resources will be accessible in the app locations that we have specified in the manifest.json. So technically, placeholders or app locations are iframes in a product at a predetermined location. So this could be a sidebar location inside the Freshdesk support ticket view, or this could be a full page application which could take the entire space in the product, and so on. So we also see that in the developer docs. You can also refer that in the code labs as well. So let's go into the app directory and also cover about one more thing, which is the client object. So we call it the fresh client. Apps communicate with the product via Fresh Client, as you can see here, and Fresh Client acts as the bridge for performing certain actions, for example triggering notifications, opening modals, passing context information, and so on. So it also exposes APIs that are required to avail data storage and other capabilities. So think of Fresh Client as the bridge between our app and the product. So that's how the code within the iframe of our application communicates to the product. In case if you don't have the Fresh Client, it may not be possible to obtain the client object. So in your app.js, you'll be retrieving the client object in this way, basically using the app.initialized method, which will give direct access to client object for that particular placeholder location or the particular app location, and using that we'll be able to invoke the platform features or make use of them easily. Alright, so let's quickly jump back to our code labs. Now that we have taken care of the setup and the prerequisites, we can quickly cover the application UI as well. So as you see here, this is the preview of the UI that we have in our template.html. So as you can see below, this is the markup for the template.html. So this is a very simple HTML, nothing fancy. The one thing that you have to keep in mind is that it's built using Bootstrap framework, so it is compatible with that, and also it requires the Freshdesk or the product style sheet. As you can see here, the UI has two actions, primarily create issue, which you can see here, and view issue details. The create issue is pretty much self-explanatory. You make use of the platform features to make a REST API call, and then it will create an issue in the corresponding GitHub code repository. And we also have view issue details, which will display the issue details in a model within Freshdesk. So we will see how that is implemented, but for now there's just the UI markup, and you can find the code below, that is over here. You'll also be able to find in the template.html under app directory already. It's a very simple markup based on Bootstrap. Now let's see how we can make a REST API call from our application. So before we jump back to our application, which we soon will be doing, I want to quickly cover how we will be creating and displaying the details in our application. So REST APIs enable the communication. Technically, they are the means through which we'll be interacting with a third party. It could be GitHub or Dropbox or any sort of third party. We would require the REST APIs to enable this communication. So we can refer the GitHub API developer docs to know which APIs are responsible for what. And in this case, I know that this particular endpoint will let us create issues on GitHub, and similarly we have the endpoint that is responsible for getting the issue details. So we will be making use of request method in this case to make a API call securely, and you'll see how. But before we get started with all of this, there is one input which is required. It's the point number 1, right? So we need to know, or the app needs to know, against which GitHub repository it needs to create a particular issue, right? So we can do that using the installation parameters. So installation parameters are like inputs that are required by an application during installation. So when an admin or agent installs an application, these are kind of the one-time values that they will provide during an installation, and based on this the app starts functioning. So in this case we would be requiring the GitHub repository name. So we will be making use of EPROM.json to provide this value. And of course, looking at it, you might wonder it's just a JSON, but it's one of the convenience offered by the EPROMs in our developer platform. You can just throw a JSON, and this declarative style will render the forms that is required. So let's quickly jump back to the code and check what we have in the config directory. So we have the EPROMs.json already filled in, And as you can see, it has the properties that are required, or the meta details that are required to render the field properly in the installation page. So this is taken care of. Now we need to focus our attention on OAuth config.json. So this file is pretty much important for whatever that is going to happen in the next stages of our demo. So the OAuth config.json abstracts the OAuth authorization process between our app and GitHub, and it takes care of the OAuth dance and the flow by itself. So we don't have to worry about the redirection and handling the tokens and managing the state and so on. So everything that you want to take care in an OAuth flow is taken care if you already provide the details that are required by the OAuth config.json. And before we proceed to filling in the details that is required here, let's take a step back and understand what OAuth is all about. Let's switch to the Code Labs. Let's take a quick trip back in time to understand how OAuth was even born in the first place. In the early days of the internet, users were accustomed to providing their username and passwords to access resources. These resources could be email or social media profiles or even bank accounts and so on. In case if somebody hacks or steals their credential, you'll get direct and complete access to all of these resources. There is no way to limit access or to revoke it in a proper way. Another issue is that if a third-party service wants to integrate, they would require password-based access. This opened a lot of anti-patterns and vulnerabilities. Also, there were many technical challenges to this approach. If the user accidentally changes the password after providing it in the first place, the integration or sync could break, and anything dependent on that goes for a toss. So as the internet grew rapidly, it became absolutely necessary to control the access and authorization in a proper way. We gradually started seeing advancements in mobile app, APIs, and complex web applications. Although there was SAML, it was primarily focused on authentication and was not much of an authorization focused thing. So a group of smart people sat together and wrote a specification on how to implement access or authorization delegation. It was very important to have a single spec because we can't have Microsoft and Google or Twitter fighting over each other on which is the right approach. So we had one standard approach, and that's how OAuth came into existence. OAuth stands for Open Authorization. Basically, it is a standard. It neither goes into the fine details of implementation, nor does it speak about the tech stack that should be used to implement it. It provides a specification to which everybody must adhere to, be it Facebook, Google, or Twitter. Now that being said, OAuth only deals with authorization and not with authentication. Basically, authentication is when you provide credentials to identify yourself. OAuth, on the other hand, attempts to provide access based on user consent. It deals only with the access authorization part. So if this is all confusing, let's think of a very simple analogy. Let's say the virus is gone, the lockdown gets over, and you plan a trip to Goa. You would have obviously made a hotel reservation. At the reception, you would initially identify yourself. After that, the receptionist hands over an access card to you. This card will give you access to your room and other resources such as buffet, bar, or swimming pool. Also, you can use it only to access your room, and that is the permission route, right? The card cannot be used to unlock a staff room or some other person's room. Another interesting thing is the card does not need to know your ID, and you don't have to know anything about the card, whether it's magnetic stripe or any other technology. Anyone who possesses it gets access, and that is also the reason you can't hand it over to a stranger, or you can't afford to lose it. So OAuth works in the same way. Just keep that analogy in your mind, and let's analyze how it works out in our case. So before we understand the flow, let's get clear with the terminologies. I have a quick thing to show. So let's get clear with the terminologies. It is actually very simple. Our intention here is to access the repos and to create issues in GitHub. So these are technically resources. And where do these resources sit? They sit at GitHub servers. So we can call them resource servers. Although it is over there, it is still owned by us, right? So in some cases, this does not always have to be an individual, like a particular person, say. It could also be a company or even a microservice. So in this case, the resource owner is just me, or it could be you. So cool. There are a couple of other things in the picture as well. GitHub doesn't hand over stuff directly. We need to be authorized first, hence the authorization server. The client in this case is our Freshworks app. Cool. Now that we are good with the terminologies, let's look at the OAuth flow. It might look a little bit crazy, but keep an eye on the numbers and the direction of the arrows. So first, as you can see over here, let me zoom in. So when we will be running the app, the client would be initiating the flow, which is our Freshworks application, right? This would happen when we are filling the app installation parameters, or when we are trying to access the app in the sidebar location for the first time. So once that's done, you can see that it would talk to the GitHub authorization server based on our configuration done in OAuth config JSON. So it would say that, hey, I need to access a resource. Here is my client ID, and these are the permissions that I seek, and here is my redirect URL. Send me back to this URL once you're done. So what the authorization server does is that it checks with the resource owner. Of course, this all happens in the browser. The resource owner, either me or you, so the person gets to see a dialog saying, hey, this client wants to access your repo and create issue and do stuff. Do you want to grant it? And as you can see, I'll be like fine with it. So I'll say, yeah, I consent to grant access to the client for XYZ permissions. So you might sometimes see a login dialog. In case if you haven't logged into GitHub at all, it will first authenticate you, but that is the responsibility of GitHub and not OAuth. And once that is done, OAuth will show the authorization dialog. So as you can see here, the client has spoken to authorization server, and authorization server has requested for consent. And once the consent is given, let's go to the next step, which is step number 4. The authorization server will be like, all right, you got the permissions for the resources. So here is a code or a ID that represents consent. So this code is also called as the authorization code, and this reaches the client. So the flow that we are speaking of by default is the code grant flow, so in which a code is returned, and so far this code does not give us the access. So it's sort of like a temporary thing which is handed over to the client as a representation of consent. So now the client has to do one more step. It has to exchange this code securely with the authorization server for an access token. So this step is very similar to how we get the access card in the hotel, right? So the client, if you remember, it will also have client secret, which means all of this communication, which is marked in green, happens in the back channel, which is server to server communication. So our platform will communicate back to the authorization server with the token, with the code and the client secret, and now it asks for the access token in exchange. So the authorization server checks the code and the client secret. It says, all right, I know that it's you, thanks for sending this, and then it gives the actual token. So step 6 is where we get the actual access token. So this is the flow, basically, sort of summarized here. There is also the browser which is in place. I just simplified it to just 3 actors here. But if you want to know about the actual specification, you can go and check the OAuth spec doc, which is much more detailed. The reason why I'll highlighted in the highlighted with green color, the last two arrows, is that this is where the exchange happens for the access token. So good, now that we have the access token, what are we going to do? So every time when the resource owner is willing to access or do some operation, the client will talk to the resource server, basically the APIs, right? So through the APIs we get access to the GitHub repos and issues. So what happens is, with the exchange token that the client has obtained, it will talk to the resource server saying, hey, I need to access repo, create issues and do some stuff. Here's my token. And the resource server will be checking this internally. It will verify if it's the right token, and if it's right, the appropriate resource will be returned, and it will say, hey, here's a resource. So this is based on the permissions that the resource owner has consented for. So there is very little chance that something wrong could happen, because the user can approve or disapprove at this stage if they find the permissions not all right. So in all of this flow, you saw that this deals only with authorization and granting access. So that is the OAuth flow in a nutshell. We just saw how it works in our context. And all right, now let's go back to our code labs and see how it works technically. So now that we have seen a little about OAuth, I think we can get started with creating a client in GitHub. And once we have done that, we can configure the OAuth config.json in our application to take care of the entire OAuth flow. And let's get started. All right, the first step, we go to GitHub, and once we are there, we need to go to settings, and inside settings we need to go to the developer settings tab, and we need to go to OAuth apps. So this is where we get to create a client for our application. So I'm going to create a new OAuth app. I'm going to call it let's say codiv, and homepage could be anything, or application description as sample app. Now notice the callback URL. So in OAuth process, in the OAuth flow, there needs to be a callback URL. So this is where the code will be sent back. So if we refer to the code labs, since we are on local testing, I need to provide this callback, because the code or the ID will be sent back to this URL. And done. So we have created a sample OAuth application, and it has its ID, secret, and other details that we can see here. So basically this is the client that will display which resources that we are going to access based on the scopes that we will be providing there. So let's use these details and fill it in the OAuth config.json. So I'm going to provide it here, and as a safety measure, the client secret should be private. It should not be exposed. So please rotate it if you are, if in case if you have made it public somewhere. So we have filled these two, and the authorization URL and token URL are extracted based on the GitHub developer docs. So this should be a similar case for any third-party APIs. You must be able to get them from the developer documentation. And in this case, as you can see, we have specified the scope. So in this case, we are going to perform some actions on the repo, and so we would require the repository, the repo scope. So there are other scopes as well, which you can find in the GitHub developer docs. So they define what exactly which resource our application or our client is going to access, right? So that is given, And the other parameter that we have here is the token type. So if it is account, it is stored at an account level, so probably at the admin level. And if it's agent, the other value for this is the agent, in which case each agent has to authorize himself or herself while they are making use of the application. So the auth config.json is provided here, and our sample app is also configured. So let me add a very simple logo to it. All right, we have saved the profile, the application logo. Should be easy to identify. We have provided the configurations as well, which should be good to go. So let's go back to our application, and let's try to run our application. I'm going to open the terminal. Let me resize this. I hope it's visible. The command to run the app is fdk run. I'm going to run the app. Great. So as you can see here in the console, we also have the link to test the installation page. So as I said earlier, we need to provide the repository name, and for that let's quickly jump back to GitHub and go to our sample repo. So in my case, I already have a sample app repo created, which is this dummy repository. And as you can see, this is my, let's say, sample. This is the repository URL that I have. So which means if I go back to my installation page, I need to provide this. And as you can see here, the app has started an OAuth Flow automatically with GitHub. So we are authorizing the client or our Freshdesk app, as you can see here, and it shows the scope. So basically, they are the permissions, right? In this case, we are requesting permissions for our repository, so that is why it is listed here. So if we expand it, we also get to see exactly what this permission entails. So we're going to just grant this permission, and in this case I'm just going to grant it and authorize basically. Also, as you see here, it will redirect us back to the callback URL that we specified. So to add more technical detail, we are doing a code-based OAuth grant, authorization grant. So if we authorize, it will, okay, it's requiring me to add a password. Great. So once I provided the password, which is of course on GitHub side, so once I authorize the app, it basically sent the code back to the callback endpoint, and based on the client secret that we mentioned, it generates the access token and stores it securely. So now the OAuth flow is complete, and we have the access token with us. Although we may not be able to see it, it's obtained and it's with us. So this access token can be used to perform actions on the repo. I also show how this access token is used while making REST API calls. So in this case, let's just fill the details for the app installation. I have provided the details and it's successful. So you can see at the top. Now if I go to the Freshdesk account and on a sidebar location, I'll be able to see this app being rendered. So let's go back to a sample ticket. Ensure that you are in development mode, and once I'm here, I would be able to see the UI completely. So as you can see here, we have create issue and view issue details. Also, we have authorized our app from the installation page directly. So in case if you haven't accessed the app installation test page yet, you might be presented with option to authorize the app from here. This would be the same flow that we saw. All you need to do is authorize for the repository scope, and it would automatically obtain the token and save it in a secure manner. So of course none of this would be visible to us. It's taken care by the platform, in this case the FDK. All we get to use is the access token reference while making the request API request methods call. So we will see how it works as well. Let's jump back to the code. I'll probably minimize the terminal, and let's zoom out a little bit, and let's go to the app.js. Let's consider this as a starting point, because as you can see, this is exactly where we obtain the client object. So as you can see, once we invoke the app lifecycle method app.initialized, we get access to the client object. So in this case, we are sending it to the window, and we are calling another method. So if we go there, it's right over here. It's just registering the click event handlers. As you already saw in the markup, the two buttons have the ID, create issue and view issue. So this is just a simple click handler, and upon clicking create issue, it would be able to create the issue. So but one thing that you would observe is that the create issue is empty and the function needs to go here. So as I said earlier, we can use the code labs as a reference and copy the snippet here. So we'll copy this snippet and paste it here, but let's also take a moment to understand what's happening. So we are getting the ticket details, and based on that we are checking if the ticket already exists and then proceeding to create it. So that is what we're doing, but then it also requires another function to be present. So let's go back to the code labs and copy this part, and let's make sure we add it here. So as you can see here, this is the request method call that is being made, and this is the endpoint basically until the issues. So one thing that you would have to pay attention here is how we have made use of the IPROMs. So we have referred the IPROM. Since it's a secure IPROM, it has to be only accessed by reference. So that is why we have used this templating technique. This would substitute the value that we obtained in the app installation page. So a post request would be made to this endpoint with this options object. And what does this contain? So this is similar to the same options object that we have in Axios or request, right? So in the authorization header, we have attempted another templating technique, and here it's very clear that we are substituting the access token. So as I said earlier, I mentioned that we have the access token with us, but we won't be able to see it, but we can only refer it. So this is how we refer it, and the substitution automatically happens. We don't have to worry about it. So for the body, we need to provide the title and the body of the GitHub issue that we are providing based on the ticket details that we are obtaining it from here. This is a very simple function. If you go to this function, you can see that we are making use of the ticket data object, and once we have that, we are proceeding to check and create issue. And in this case, we are actually checking the database, data storage, and then creating the issue. So that is what we are doing here. But one thing to note Oops, sorry. But one thing to note, uh, in our code snippets that we have pasted here, we have the logic to create, but we don't have the logic to view it. So this makes a request call based on the access token it obtained, and also it substitutes a GitHub repo, and then it creates a ticket. But one thing to note, we haven't made use of the setData function. We will see later in a moment. Let's quickly jump back to our application in Freshdesk. Also, let us have the developer mode, the developer tools open to see what happens. And I'm going to create an issue. So this is my GitHub repository. I don't have an issue yet. And I'm going to press this button. As you can see here, a GitHub issue is successfully created. We have also seen that in the log over here. And if I go to my repository and if I refresh, we have the issue. So as you can see here, the issue title and the issue body is same as the ticket heading and its description. So we got this using the ticket data object using the client.data.get, and based on that we proceeded to make an API call, REST API call, using the request method. And once we did that, we were able to successfully create a ticket. And as you saw here, we have authorized with GitHub already, and that's how we obtained the access token, and that's how we were able to create it in the first place. So in case if I accidentally press the create issue button again, this will end up creating duplicate issues inside GitHub. So this is a situation where at least I don't want to be. It has to be unique. So that is exactly where data storage could be very helpful. Also, it helps in caching the response so that we will see it soon. So it can also act as a cache, and it can also act as a way to avoid duplicate tickets being created. Duplicate issues being created. So let's go back to our code labs. We also have a preview here, and now we're going to avoid duplication using data storage. So data storage, as you know, would help us prevent duplicate records, and in our case we're just going to set a small key value pair, and that is a check is going to be performed every time an issue is getting created, so that we don't end up creating duplicate issues. So we have the logic for set data already here, except that we need to uncomment it. So I'll probably uncomment this. I'll save it. And all right, we don't have the logic for set data, so I'll also copy that from here. I'll also explain what is inside the code. Basically, it is very simple. We are creating two key value pairs, and it sort of contains a mapping between the tickets and the issues, and based on this we are saving the mapping. And once the mapping is saved, every time we press the create issue button, it's going to check for this and then only proceed to ticket creation. So let us try to let's say create the issue again. Okay, as you can see, the issue is created successfully, but also the mapping data is saved. So now let's try to create it again, and this is where the data storage magic works out. So since we have already stored the mapping, every time when we click on the create issue, it's going to prevent the app from accidentally creating the ticket again. So if we go back to our GitHub issues, we can clear the unwanted tickets, and that would have only one GitHub issue. So the other now that we have also the logic, this would prevent duplication. So the next task is to view the issue details, and to do that I'm going to make use of modals. So let's see what is already there for the view issue function. So we have a function call here, but there wouldn't be any matching code here. So let's implement it. Let's go back to our code labs. We are going to make use of the interface methods. We can see what they are. So basically these methods help us work on the product interface and UI, and based on the interface methods we'll be able to show notifications, show modals, manipulate visibility of fields and UI controls, and so on in the product. So in our case, what we're going to do is very simple. We are just going to view the issue. So I'm just going to copy this, and then let's go back to our app, and there we go. So what I'm doing here is I'm going to view the issue, and for that I'm getting the ticket details. So the same function that we saw before, I'm making use of the ticket data object here, and based on that, let me go here, yeah, and based on that I am triggering a model. So this is the interface method. I am triggering a model, and of course a model requires its own view, and for that I am using the HTML file which is sitting inside the model directory, which we saw earlier. It's over here, and I'm also setting the title of the model, and every model can also be opened with a context. So basically the data that is required for the model to open, and we can't just open a model and then expect it to retrieve the GitHub issue details. We need to pass some context. So in this case, the context that we are passing is the ticket detail itself. So that's the data that we obtain from the ticket data object, and we are using it to invoke the model. So great. Now let's go back to our code and then see if it works. Let's close this. I'm going to my code, clicking on the issue details, and here we go. So it opened the model and also showed the GitHub issue details. And in case if you're wondering how it worked, I can go through the model. So model HTML is a very simple HTML. You may wonder how we have the content here. I will explain that part as well. So we just need to go to the model.js, which is the JavaScript file associated with it. And as you can see here, when the model is being opened, so this is the entry point, and any application that you use will always be making use of the app lifecycle methods, similar to how we had for app.js. So in this case, we're getting the client object, and we are making use of the instance methods. So basically, instance methods give you the context and information related to the other applications which are rendered in different locations. So, I mean, same application can contain different applications, and in order to communicate between these applications, we need to make use of the instance methods. So we are getting the context, and we are passing it to a separate function. And if we go to this function, we see that we are getting the issue. So this is a function call that we have, and we have also passed on the context to this function. Basically, this context is the one which we passed during the model invocation. So let's go to this function and then see what we are doing. So we are here. We have a database data storage call. We are checking if there is a mapping, and if there is a mapping, which of course, yeah, it got created during our issue creation, right? So based on the mapping, it will fire a callback function. So in this case, what we are doing here is, just a second. What we're doing here is this. So this is the callback function here, and as you can see here, it's fetching the issue number, and based on the issue number, we're just going to make a simple API call. As you already know, we have obtained the authorized our app, and hence we have the access token. So this is a get call to retrieve the details specific to an issue ID, and once we have that issue ID, we are rendering the HTML on the view. So this is a very rudimentary approach, or it's a very simple approach to rendering the UI, and that's how it's very simple. But you can make use of other templating engines like handlebars to render sophisticated UI, and make much better use of templating. So once you do that, you'll have an UI as simple as this, and you'll be able to create issues, prevent duplication, and also view issue details in one shot. So this covers the complete flow of our application. We managed to build the app from the code labs, and then we saw how it works end to end. So I'll also explain the reason why we are making use of the request methods. So every time, let's go back to the network inspector. So as you can see, let me zoom this up a little bit. In case if you're using an AJAX call, or in case if you're using any other client, any other library to make API calls from the front end, you would have two challenges. So one would be the CORS issue, cross origin site request issue, and the other would be the ability to safely pass credentials. So here's the magic. If I click on the view issue details, you would notice that certain API calls are being made. So most of these are resources, and this is the proxy service that we have, this one. And as you can see here, the data that is being passed is actually the same thing that we had in the request method option. So as you can see here, the access token is still the template that we specified, and we are not able to see the actual access token. So this is by design, and this is how it prevents leaking secure information on the client or on the front end. By default, if you place any sort of credential or any sort of sensitive information on the client side code or on the front end, it will always be vulnerable to a security threat. So since we're making an API call, we're making use of the request method, and this substitution automatically happens on the platform side. So this is not visible to us. This is totally abstracted and hidden from us, and only the platform knows the exact access token that maps to this particular application and session, and based on that, it is able to make a secure API call. However, as you can see in the response that is returned from the proxy service that we have, we see the proper response from GitHub. So however, we don't see the access token. So this is the major benefit that is offered by the use of request method. And as you can see here, I haven't used any server components at all. So this is still a lightweight app sitting on the client and making API calls in a secure fashion, and that is a advantage that we have with request method. So we saw how we can make use of modals, how we can make use of instance methods, and how we can make use of the OAuth flow, and we were able to see the complete app working. So let's go back to our code labs. To quickly recap, we saw how to create and configure an OAuth client, and we also saw how we can make secure API requests using request methods and OAuth. We also successfully remembered state information using data storage, and we also displayed notifications from the app. We also managed to pass on the context from the main instance of an app to a model launched by the app, and we also saw how the request method works in a secure manner in detail, right? So I think this is pretty much enough to build certain complex apps without even touching the server part. But there are certain situations where you might have to impart some capabilities using server-side code. So to address those situations, we have serverless applications, and each Freshworks app can also contain a serverless component. So we will see how that works in the next session. And for now, please feel free to replicate this setup on your machine. Try this out. If you have any questions, please reach out to us in the forum. We'll be very glad to help you.